morning, dear students. In the previous class, we were discussing about simple microscope, and we derive a result for the angular magnifications or magnifying power for simple microscope. And today we're going to discuss about compound microscope. You please note down this today's topic is compound microscope. Compound microscope we'll discuss today. As I told you, what is simple microscope? That simple microscope is a single convex lens, also you can say, and we derive a result for the magnifying power or angular magnification for it. Now this is compound microscope. Now what is compound microscope? That in simple microscope we used one convex lens, but in case of the compound microscope we will use two convex lens. One lens that is towards the object, that will be objective lens, and the other that is towards the observer's eye, and that will be your eyepiece lens. That means those objects which cannot be identified by the help of simple microscope, we will use compound microscope to identify those small objects. That means compound microscope will be more powerful. That's why the two lens will be fitted in a compound microscope. Let us see the ray diagram of compound microscope. As I told you, the compound microscope will have two lens. That means if I suppose this is the first lens, this is convex lens, and this lens will be towards the object, and this is your principal axis. I apologize that in the lectures of simple microscope I somehow told this is as normal. Extremely sorry for it. By mistake I told this is a normal, but as you know, all of you know that this is not normal. This is principal axis. Mistakenly I told in the diagram, ray diagrams of simple microscope. You correct it. Though I have given a apology message in the description, you can see it. So this is a convex lens, and this lens will be objective lens. This lens is objective lens, and let us suppose this is its optical center. And if I consider this is f0, just FO, and this is twice FO. This is also FO, this side also this is FO, and this is twice FO similarly. Now I am going to keep the object between FO and twice FO. As you can see here, this is the object I have placed, and suppose this object to be AB. This object is AB, and this object has been placed between FO and twice FO. Now where image will be formed in this case, that this ray will go parallel to principal axis. After refraction, this will be passing through the focus. This ray that will passing through the optical center will remain undeviated so far. Okay, that means like that. So we can find that we have found that the image is forming somewhere here beyond twice f, and this image is going to be it is AB was the object, so image will be B dash A dash. Okay, so A dash B dash is the image for the object, AB for the objective lens. Am I clear? This is objective lens, as I have mentioned. Now what we'll do next, now we'll put one more lens, and this lens will be bigger in size in comparison to the first lens. So here I am going to put one more lens. And this lens will be known as eyepiece lens. Okay, this lens is known as eyepiece. So this is objective and this is eyepiece. Suppose it is given LE and E is the optical center, suppose, for the eyepiece lens. Now as you have found that ADS-BDS is the image for the object AB, now this image ADS-BDS will behave as the object for the eyepiece lens. Okay, this point we have discussed for a couple of reasons this technique, that image of the first lens will behave as object for the second lens. That means, again, let's see what the image form in this case. This is going to what? Parallel to principal axis. That means I have to extend a little bit. So this will be passing through the focus. This will be passing through the focus. These are as usual rules, as you can see here. And this is suppose F, again the focus, this is suppose FE. This is focus of eyepiece lens I have considered, and this is focus of objective lens, so it will be very easy to understand for you. And this will be your FE. That means this object will be placed between optical center of the eyepiece lens and principal focus of the eyepiece lens. So, and one more ray, this ray will be passing through the optical center of it, and so after refraction this will remain undeviated. This is going this way and will be coming in the same direction, and they're going to be making an angle and making an image somewhere. Let us see where they make the image. Be very careful when you're drawing the image. Okay, so just take a look over it. I'm just making this for you. That means the image will be take place somewhere here. This is the image. This is a final image. This is going to be your final image. Okay. So this is ADS-BDS, and the ADS-BDS was the object for eyepiece lens. That means this will be your A-double-S, and this will be your B-double-S. Okay, this is B-double-S. So this is the simple image as you can see in this diagram. So this is the ray diagram for compound microscope. Okay, so let us go for the explanations of the diagram again. So this is objective lens and this is the object AB, and ADS-BDS is the image for the object AB. That's fine. Now as I told you that here we consider two lenses. One is objective and next lens is slightly bigger in comparison to the objective lens, and this lens is your eyepiece lens, like that. Now image of the objective lens will be object for the eyepiece lens. Now this is ADS-BDS. ADS-BDS will be the object for eyepiece lens. Now this object will form the final image for the eyepiece lens here. A double S, B double S. So A double S, B double S will be the final image for this particular compound microscope. Now we'll go to find out here magnifying power or angular magnification. So here we go for it. So we'll write now magnifying power M, magnifying power M, and this magnifying power M is also known as angular magnification. That thing you know. So this will be what, as I told you, that angle subtended by or angle formed by image and angle formed by object. Angle formed by image and divided by angle formed by object when it is at LDDB. What is LDDB? I told you that LDDB is the least distance of distinct vision, and that is 25 centimeter for a healthy human eye. So that this is how we find a magnifying power or we find a angular magnification. Now if I consider that angle formed by image, this is the final image. In this case it is a final image. Okay, you can write final image. So this is the final image. A dash B dash. A dash B dash is making an angle with this one. Suppose this angle to be beta. Okay, this angle supposed to be beta. So beta is the angle that has been formed by the final image, as you can see here. Okay, A dash B dash is the final image, and that is forming an angle beta. Next, angle formed by the object when it is at least distance of distinct vision. If I consider that this is the least distance of distinct vision, that means where final image has been produced, that one we have considered as least distance of distinct vision. And if I consider that this is the least distance of distinct vision, this is least distance of distinct vision, that has been abbreviated as D. Now this object will be placed at here, since this is your least distance of distinct vision. So I'm putting this, I'm considering this object here. Suppose this object is B double S C. Now B double S C again will make again one more angle, and suppose this angle, this is alpha angle, and this alpha angle has been made by the object when it is placed at least distance of distinct vision. This object is this object. Difference is that now this object has been placed at least distance of distinct vision in order to find the magnifying power. So this is beta and this is alpha. That means we can write that M is equal to angle formed by image is beta, angle formed by object is alpha. So M is equal to beta by alpha. So if I consider that these angles are too small, so you can write if angles are too small, if angles are too small, then we can write that alpha is equal to tan alpha and beta is equal to tan beta. Have you got it? And for that the angle should be considered as too small. So I can write that magnifying power M is equal to tan beta upon tan alpha. Okay, now we'll find the tan alpha and tan beta separately. How can you find the tan beta in this case? This is tan beta, this is beta, and beta belongs to the triangle A dash B dash E or A dash E B dash. Actually, beta will be belongs to triangle A double S E B double S. But instead of considering the big triangle A double S E B double S, we can consider the triangle A dash E B dash, because considering A double S E B dash or considering A dash E B dash are completely same. So from triangle A dash E B dash, if I find a beta, this will be perpendicular upon base, or not, tan alpha, tan beta perpendicular upon base. A dash B dash is the perpendicular, E B dash is the base, so I can write A dash B dash by E B dash. A dash B dash by E B dash. Okay, A dash B dash by E B dash. This is for triangle. This is for tan beta from triangle A dash E B dash. Then it will be tan alpha. If I reverse it, generally tan alpha will be belongs to this triangle. This is alpha. So B dash E C triangle. This is B dash E C. Okay, B dash E C. From where you can find the tan alpha. If I find a tan alpha from here again, CB dash by CB double dash perpendicular CB double dash by EB double dash. CB double dash by EB double dash. This is your tan alpha, correct? Perpendicular upon base. Since this tan alpha will be reversed, if I multiply, this value will be reversed, and above you will find EB double dash and below you will find CB double dash. Okay, now you have, I think you have cleared this ratio. Now from here we can find the magnification now. Magnifying power now, M is equal to, what is A dash B dash? This is A dash B dash. A dash B dash, we have no information regarding that. What is EB dash? EB dash, this is EB dash. What is EB dash now? EB dash is the object distance for eyepiece lens. So I write here UE. UE means object distance for eyepiece lens. This is EB dash. And this is object distance is going to be minus. This is EB double dash. This is EB double dash means this is E. This one is E. E B double dash. E B double dash. E B double dash is what? This is E B double dash. E B double dash is the least distance of this string, and this is D, and this is going to be minus. This is minus. So what is left now? A dash B dash is left, and below we have left out CB double dash. Since CB double dash also have no information, so this is number 1 equation. Okay, this is CB double dash. Now this is M is equal to minus D by UE into A dash B dash by CB double dash. Since we have no information regarding A dash B dash and CB double dash, so we have to find the value of A dash B dash and CB double dash. So how can we find the value of A dash B dash by CB double dash? That means this value, how can we find this value? We can consider here the triangles. That we can consider here the two big triangles. First triangle AOB, we can consider AOB. That means you can write triangle AOB will be similar to triangle ADAS-OB dash. Will be similar to triangle ADAS-OB dash. Understood? Triangle AOB will be similar to triangle ADAS-OB dash. Clear? These two triangles, ADAS-OB dash and AOB. So from here we can write ADAS-B dash by AB, bigger side, ADAS-B dash by AB. Have you got it? ADAS-B dash by AB. Then I can write OB dash by OB. We can write is equal to OB dash by O, this is OB dash by OB. This implies A dash B dash by. Now as you can see, this is CB double dash and this is AB. CB double dash and AB are similar, that means same. Why? Because this is CB double dash and this is AB. So AB and CB double dash are similar, they are object only. So we can write, instead of AB, I can write CB double dash is equal to, what is OB dash now? This is OB dash, this is OB dash, OB dash. OB dash is the image distance for objective lens, that is positive. So this is PO. PO means image distance for objective lens. This is OB dash. Then you have CB double dash. Where is CB double dash? As you can see, sorry, this is OB. OB means your, this is OB. OB. If OB dash is the object image distance for objective lens, OB is going to be your object distance for objective lens, and that is going to be minus UO. That means we can find the value of, now we have found that A dash B dash by CB double dash is equal to minus PO by UO. Now this value A dash B dash by CB double dash, this value we can put in number 1 equation. So I will write now from number 1. From number 1 equation. From number 1 equation, what you will find? That M is equal to minus minus will be cancelled, so it will have D by UE into, in the place of A dash B dash by C double dash, we'll put the value minus BO by UO. So this is minus, so I'll write it before, minus BO by UO into D by UE. And this is normal magnification, magnifying power for compound microscope. What is M is equal to minus BO by UO into D by UE. Understood now? Okay, this is the general magnifying power for compound microscope. Now there will be two possibilities will be arises. What is the possibilities? If the images are formed, if the images form at least distance of distinct vision, then what will be the magnifying power for compound microscope? And second one is, if the images form at infinite distance, what will be the magnifying power for the compound microscope? First is, if the image is at least distance of distinct vision, and second is, if the image is at infinity. So we'll look the first point now, that if, number 1, if image is formed at least distance of distinct vision, that is, if images form at LDDV, what will be the magnifying power? So we have to consider, bring now the lens formula here. So we know from lens formula, what is from lens formula? We know the lens formula is equal to, this is for eyepiece. Have you understood for eyepiece? Because image, a final image will be produced, and this will be with reference to the eyepiece. So whatever we'll find now, that magnifying power, that magnifying power will be found with respect to the eyepiece lens. So we'll write for the eyepiece. That means this is the eyepiece lens, from where observer will see the final image. So we'll write here 1 by Fe is equal to 1 by VE minus 1 by UE. This implies, that means 1 by Fe, that is positive, is equal to 1 by VE minus object distance, where object is produced, where image is produced at least distance of distinct vision, so it will be minus D, and this is minus 1 by UE. UE is the object distance minus, so minus minus plus. Now I am to bring this d by u here, so that I can match up with this equation. Now if I multiply both sides by d, multiplying both sides by d, what will you find? D by Fe. Remember, I have multiplied both sides by d. D by Fe is equal to -1 plus d by ue. Okay, simply I have multiplied by d. So once I multiplied by d, what I find? That d by u is equal to d by ue is equal to 1 plus d by Fe. 1 plus d by Fe. Okay, 1 plus d by Fe. This is d by u value we have got. If I find d by ue here, so this is 1 plus d by Fe. Now let us suppose this is number 2. Now from 2 equation, number 2, what is number 2 equation was? M is equal to minus BOU into d by ue. Now I put the value of d by ue here. So if I put the value of d by ue in number 2 equation, remember I am putting this value in number 2 equation. What will be the ultimate magnifying power for compound microscope when the image is at LDDB? So M is equal to minus VO by UO into, this is d by ue. The value of d by ue is 1 plus d by Fe. 1 plus d by Fe. That means this is your magnifying power. This is your magnifying power for the compound microscope if the image is format least distance of distinction, and this is for maximum case. This is maximum. This is for maximum case. That means this is maximum magnifying power. Next, if the image is format infinity, you write if the image is format infinity. Here, this is number 2 case. If image is formed at infinity. Suppose image is formed at infinity. This is not diagram for the image forming at infinity. To form the image, if image will be formed at infinity if the object is kept at focus. Remember that point. Okay, if this object is placed at focus, then will be image produced at infinity. So from lens formula we can write 1 by Fe is equal to 1 by Pe minus 1 by Ue. So 1 by Fe is equal to, this is 1 by Pe, where image is forming image at infinity. So 1 by minus infinity, object distance be plus 1 by Ue. Again same process, you multiply both sides by d, so it will become d by Fe. Okay, d by Fe, this is becoming, this is value is 0, this plus 1 by infinity will have the 0 value, 1 by u, this is d by ue. Okay, so we have found this is d by u is equal to d by Fe when the image will be formed at infinity. Now if I put this value, this is d by ue, the value of d by ue here, what you have found? D by Fe. Now from 2 equation, from number 2 equation, what is the number 2 equation? The number 2 equation is M magnifying power, M is equal to minus UO by UO. That in the place of d by ue, what you are going to put? D by Fe into d by Fe, and this is for minimum case. That means this is minimum magnifying power for compound microscope. So after all, we have found the 3 magnifying power in this case. M is equal to minus BOUO into d by ue. This is general magnifying power. Secondly, M is equal to minus BOUO 1 plus d by Fe, that is for maximum magnifying power when object image is at least distance of distinct vision. Finally, we have got when image is at infinite distance, then M is equal to minus BOUO into d by Fe. And what is the significance of becoming this value of image is minus? Because image is inverted with respect to this object. That is why it is minus, but in case of simple microscope it was not minus, it was positive since the image was not inverted. So this is very important, and very very important and very interesting topic of class 12 physics. Compound microscope, practice art, very essential for exam point of view. If any problem, just inbox me, I will try to come back. And simple thing these are, just please go to the ray diagram very nicely. Ray diagram is very important to understand. I hope you have cleared all these things, or you will clear. Thank you.